Three charges are arranged on the vertices of an equilateral triangle as shown. Find the dipole moment of the combination. Here, three charges are like this. Here there is negative charge. This is 2q and this is minus q. And separation means d. This side is d. Each angle will be 60 degree. This is equivalent to two dipole placed at 60 degree. So dipole moment of each dipole will be same. So P will be equal to 2AQ. Here 2A equal to D. So DQ. Now resultant can be found by using formula of resultant of two vectors. So P resultant will be equal to square root of P square plus P square plus 2PP cos 60 degree. So this will become P root 3, but P equal to DQ. So it will be DQ root 3 and the unit will be Coulomb meter. Now consider second. Question number 73. Find the magnitude of electric field at point P in configuration shown. So there are three configurations. So first is like this. There is one charge here, Q, and point P lies just above it at distance T. And we have to find out electric field at point P. So E will be equal to Q divided by 4 pi epsilon naught D square. Now, second configuration is due to dipole. There is dipole minus Q charge here plus Q charge here. And point is on perpendicular bisector. This separation is A, this separation is also A, this distance is D. Now, due to this negative charge at point P, the electric field will be directed like this. So, suppose this is E1, and suppose we take this angle theta. So, it will have two components. One component will be in this direction, that will be E1 cos theta. Another component will be in downward direction, that will be E1 sin theta. Now, consider electric field due to this positive charge. It would be directed like this. And suppose this is E2. So again, we take its components. So one component will be in this direction, that will be E2 cos theta. Another component will be in upward direction, that would be E2 sin theta. Now consider the magnitude of E1 and E2. So E1 will be equal to Q divided by 4 pi epsilon naught. And this is A, this is D. So A square plus D square. Similarly, E2 will be also equal to same. So E2 will be equal to Q upon 4 pi epsilon naught A square plus D square. So in magnitude, the two are equal. So we can write that E1 equal to E2. So here it is obvious that only cos theta components are added and sin theta components will get cancelled. So E resultant will be equal to 2E cos theta. So twice of E is Q upon 4 pi epsilon naught A square plus D square and cos theta. If this angle is theta, we are taking this angle theta, it means we have to take this angle theta. So cos theta will be base upon hypotenuse. So base is A and hypotenuse is D square plus A square to power half. Now, this will become 2AQ divided by 4 pi epsilon naught A square plus D square whole power 3 by 2. Now, if we apply some approximation and we put 2AQ equal to P, so approximation is A is less than D, so we can neglect it. So P divided by 4 pi epsilon naught, and this will become DQ. Now consider case number 3. So case 3 says that there is dipole minus q plus q, and at the midpoint there is another charge plus q, and electric field is to be found at distance d, point is to be here. So as we have seen in previous case that electric field at point P due to dipole is E, let's denote it as dipole, is equal to, we have derived here this relation P upon 4 pi epsilon naught dq. So we can write it E dipole equal to P upon 4 pi epsilon naught dq, and due to this charge electric field at point P will be, suppose it is E, so this is q upon 4 pi epsilon naught d square. Now here direction of net dipole moment due to this dipole is in this direction, and due to this charge electric field is in this direction. Sorry, the direction of electric field due to these two charges will be in this direction, and direction of electric field due to this charge is in this direction. So this angle is 90 degrees, so we have to find out the resultant of the two. So we can find E resultant due to these two. So this will be equal to root of p square divided by 4 pi epsilon naught d cube whole square plus q square divided by 4 pi epsilon naught d square whole square. Now, what we do? We can make it here d square and d square. We multiply and divide so that d cube can be taken common. So 1 upon 4 pi epsilon naught d cube is common. Then inside the root, we will be left with p square plus q square d square, and that will be our answer. Thank you for watching.